Okay, here's a short video for our week 1 practical. So we've got our Blackboard page and you'll have already seen some resources available here, our introduction, big data security analytics, and what do we mean by cybersecurity data analytics. And then we've got our live session here. Okay, so the live session, as we've said, is going to be Wednesday, 21st of October, 10 till 12. And what we're going to be looking at is this notebook. So we've got the SDAV 101 IPython notebook, and we can click on that and download linked file. Okay, so let's do that. And then if I bring up a terminal, okay, I'm in my downloads. I've got a thing installed called Jupyter Lab. Okay, so I can type in Jupyter Lab. And Jupyter Lab is a web-based IDE or web browser-based IDE for being able to work with IPython notebooks. Okay, so it brings up something like this. If you've not got Jupyter Lab installed, have a look on the notes. We've got some details there for how you go about installing Jupyter Lab and Jupyter framework. So you can look at that there. Okay, so what is Jupyter Lab? Well, we've got this section over here where we have our files, and then we've got this main section here, which is our notebook. So notebooks are made up of different cells. So here we've got a code cell, okay, that's got some Python library imports. Here we've got some markdown, some further markdown there, and I'm just double clicking on these to be able to edit them, and then I can execute a cell by saying Shift Enter. Okay, so if I press Shift Enter, it renders the cell. Note here I've got a hash before my quick example of plotting data, and that allows it to execute as markdown so that it will render the notebook as intended. And for the code cells, Shift Enter again, what I can do there is actually run that code cell. So when it's running it, you'll have noticed there's little asterisks over here, a little star. And when it finishes running, you get the number to show which cell is executed in which order. Okay, so cell number 2 now. And I can go through and execute each of these. Note there is also a play button up here, so I could click on that. So here I'll click on that button, and I'll click on that. And note what happened here. When I click on this play button, it renders a new chart. Okay. So here, what's happening then? Well, I've got a variable a, and I'm saying create some random normalized data. Okay, I'm giving it a bunch of parameters. So I'm specifying what the mean and the variance of that random noise should be. And then I'm saying how many points do I actually want. Okay, so I'm having a 1,000 points by 1,000 points in an array. We'll get onto that shortly. And I'm doing that twice, a set for A, a set for B, such that when I plot them, I end up with these two different groups. Okay, and I can change the values here. So maybe I want to put this as 0.2, and maybe I want to put this as 2.5. And if I execute the cell, that's created A and B, and then execute this cell to be able to plot that, I can see I've got two distinct groups here. I'll bring them back a bit closer to each other now. So 1.0, 1.4 say. Okay, and we can see they're now overlapping. And that's a really, really quick example of how we can plot data using a scatter plot, where we've got some random normalized data that represents two groups. This could be representing benign traffic versus malicious traffic under some conditions, and we could actually plot those together to see where the overlap is and what's happening. So just then to look at some basic operations in Python. So we've got basic variables such as numerical values, integers, floats and doubles. We've got string values such as text. And we've got basic data structures such as lists and dictionaries. So here we could say number equals 1, or we could say text equals hello everyone, where hello everyone's written in quotes to specify it's a string, just a text value. Here we've got a list. So a list is essentially an array. So I can say L equals, and then I use these square brackets to open up my array, and I can specify different elements within that array, all separated by a comma. And then I've got this dictionary object, where dictionaries are like objects, and I can specify characteristics of that object, so name value pairs. So I say name, okay, so each of my objects will have a name. This object's called Bob, and Bob might have a value, okay, so my name is value here, and my value pair is specifying 100, okay. So here I've got an instance of Bob who has a value 100. Okay, so those are very much the basic structures that are used within Python. And we can do various different things. So we can create lists of dictionaries, we can have lists within dictionaries, and we can have lists of lists, which are often referred to as nested lists. And we can have dictionaries as values within dictionaries. So all of these can be used together. And here our list has numbers, but it might be numbers and text combined. That's one of the interesting things about Python. You can mix variables. In other languages, you might be restricted to have them all of the same type. Here you can mix them. Okay, so we've got some more examples if we look further down. So more about some numerical values and how we might add those together. We've also got things such as our functions. So here we can write a function where we say def, and then we give it a function name, multiply. We might specify then two numbers which we want to be able to multiply together. We put a colon at the end, and then we say, okay, what are we going to return? So from this function, we are going to return number 1 multiplied by number 2. Okay. So if I wanted to multiply this variable here, an integer, with this variable here, a floating point number, I could just give those as two input parameters to my function, and I'll get back the multiplied result. Okay, so we've got strings. We've seen a little bit about strings, and we can change this string as we wish and see the output from that. Here we can do some string manipulation. So if I've got a variable called my_name, I can then add that in here. So here I've got a string, which was used above, plus my name is, plus my name, to be able to print out a message. And maybe I want to replace the person. Okay, so rather than saying Phil, we might have someone else who wants to manipulate this message. Let's call them Dave. And what we've done here is quite interesting, because what we can do is, taking our original string, we've actually split it out. So what we've done is we've looked for all of the places where there's a space, and we've split the message out based on that space. And then what we've done down here is that we've rejoined all of those components again with a space in between, but we've left off the last component. Okay, so that's what this -1 is all about. So it's saying join all of the elements that are in s_m starting from the beginning but terminating at the -1 position, which basically means leave the last element off. Okay, we then add our own space and we add the imposter name, and suddenly we've manipulated that string to change it from saying my name is Phil to my name is Dave. Okay, here we've got a bunch of variables, a bunch of strings in a list. We can print out that list. We can access sets of variables using indices from that list. Okay, so here if I say fruits 0, 2, that's just going to give me apples and bananas. Likewise here, I'm going to get everything except for the last one, like we saw earlier. So apple, banana, orange, but missing off lemon. We can also add items to this list. Okay, so here we can append mango. We can print that out and see what happens. And we can also remove items. So here we've removed banana, and again we can see what happens. So lists are really important, a really important data structure within Python. You can append and remove things. You can nest these lists, as we've already mentioned. You can do a lot of things with lists. Very powerful. Okay. Down here then we've got a dictionary object, so similar to our earlier example. We can create a dictionary. So I've done it slightly differently here, where I create an empty dictionary with my curly brace, and then I can add different entities. Okay, so I can just give the entity a name by saying person, square brackets, and then a string of whatever I want that name to be. So here it happens to be name. Okay, so this is my name and this is my value. So again, we're creating name value pairs. I specified Bob, and Bob is 23 and he is 185 for his height, and he has the email address bob@bobmail.com. Okay, so we can print person and see all of the different attributes about Bob. So again, we could extend this. So like we did earlier, we could create a function, and this function will essentially create a new person based on a given name, age, height, and email. So that will create the new person, just as we've done earlier. And then we can append that new person to a set of people. Okay, the set of people might be a list. So in order to be able to access that list and keep on updating it, we call the global function on people within this function. Okay, so what this means is that this people and this people are referring to the same thing. If we didn't have that statement, then we'd be appending to an array called people within our method, within our function, but it wouldn't be updating outside of a function. Okay, so here then we've got 4 calls to our function, where we've got Bob, John, Sophie, and Wendy. And if we run that, we see our output something like this. Okay, and that's the start of having a data structure. We've got a list of dictionary objects here. Okay, so each person and their associated attributes is a dictionary, and the set of multiple people within our data set is maintained through the list. Okay, so then those are all basic Python functions that we've been able to use there. So how can we make more use of this to be able to start analyzing this data, visualizing this data, doing interesting things with this data? So there's a bunch of data science libraries available for Python, which is why Python is so popular for doing this kind of work. So NumPy, or numerical Python, pandas, matplotlib, these are the 3 common libraries that we'll be using throughout the course. Okay, so if we run those here, And then the nice thing about the data structure we've made earlier, this people, what we can actually do is we can put that straight into a table within pandas. So here we're going to call our table data. We're going to say equals PD, which is a reference to pandas, as we can see there, PD dot data frame, and then we're just going to give it this list of dictionaries. Okay, so that's what people is. That's a list of dictionaries. And if we run that cell, we get Bob, John, Sophie and Wendy. Okay, so we can see that. We could go up here and we could change that to be, well, let's try Dave again. Okay, so maybe Dave has jumped in on this data set. We can see Dave changed there. And if we update this cell, so shift enter, we can see Dave appear here now as well. And that's one of the other really nice things about notebooks. If I've done some code earlier and I decide I want to change it, I can just go up to the code cell, change the code in line, rerun the cell, and then use it again later on. So for development purposes, that's a really, really handy feature to have. Okay, so we've got this table of data and we want to access the age column. So if we want to get the age column, we could say something like data square brackets age. That'll give me all of the values. It also gives me the index. Okay, just like you've got the rows here, you get the rows again here, but we can get all of those age values. And I could do things like values there to be able to list that as an array if I wish. Okay, so here it's as a table, a pandas table. Dot values means I get it as an array. I could start doing things with that. So then I could say, well, I want element 1 from that array. I've now got 41. Okay. Perhaps I want to find out something about this table. So I've got height, and I want to know who's the tallest in this data set. Well, we can see who's the tallest. How do we do that programmatically? So we want to be able to say that we want the row where height is the maximum value within that column. Okay. So this is where pandas gets a bit interesting, because it's slightly complex notation. We say data and then we say square brackets, and within this square brackets we say data height. Okay, so data height, that's going to give us this column as we've seen earlier, and we're going to say equals np.max. Okay, so numpy, it's just the max function within numpy, and then the maximum value from data height. Okay, now what this is really saying is show me where data height is equal the maximum value within data height. Okay, and then, as we've already said, it's within these square brackets and we call data again. So why do we do that? So the easiest way to explain it is if I do it. And again, that's the beauty of the notebook. So suppose I wasn't going to nest it. Suppose I just had data height equals np.max data height. What are we going to get? We get a table like this, which tells us false, true, false, false. Okay, so this is essentially Boolean indexing is what it's called. And this is telling me where is this query true and where is it false. Now in this case, because we're comparing against what the maximum value is, there's only one case of it being true. However, if I was searching for all cases where someone was aged 21, then I might have multiple cases which might be true. Okay, So here we've only got one case which is true. So if we then put that within the square brackets when we call data, what that will essentially do is say, get me all rows from data where this statement is true. Okay, and if we think of it like that, we then get the row which is true, which is John, who is 185. Okay, same sort of concept. We can say who is the shortest of our users. Okay, we run that, we get Sophie. And if we want to do a very, very brief plot of this data, we could just say data.plot and see what it does. Okay, what it's going to do is essentially plot any column which is numerical data. So here it can plot age, it can plot height. It can't plot name and it can't plot email because there's no real sensible way of doing that at the moment. Okay, so it will take the numerical columns and it will plot those. So data.plot, plt.show, so that we render it to the notebook, and we can see for each of our users what's their age, what's their height. Okay, so that gives a really, really quick run through of the notebook. But the idea is you download the notebook, you get up and running with the Jupyter Lab environment, you try and run through this notebook, you try and ensure that you understand what we're doing at each of the cells. Hopefully, having talked through that, coming up here now and looking at this quick example, some of the code syntax starts to make a bit more sense. So you have a look at this notebook, and what we'll be doing, we'll be talking about this more in our live session. And if you're interested to know more, it's worth spending some time to research into pandas, matplotlib, numpy. These are core libraries for manipulating numerical and tabular data and being able to visualize the results. We'll be using them a lot throughout the course. Okay, so they're really, really important to learn. So there's lots of great examples online as well, so it's worth looking at those. I've put a link here to a free ebook provided by O'Reilly, which is a whirlwind tour of Python. So if you do want to brush up on your Python a bit further, I definitely recommend getting all of that. So that's our brief tour of our Jupyter Lab and the Jupyter Notebook for this week, and I'll see you in the practical. Bye for now.